For this session, Dr. Devendra Kumar on the dais and also Dr. Nutan Kaushik, the co-chair. Okay, my apologies. The chairperson, Dr. Nutan Kaushik, and co-chair, Dr. Devendra Kumar. I would now like to hand over the mic to Manasvi. Thank you.
I can do that.
Good afternoon, everyone. Oh, okay. So this is the last session before the validity session. So, and everybody had a very good lunch. So you have a duty to keep them awake.
I will do
Okay,
it.
good.
Yeah.
So we start the first presentation by Manasivasini Sridhar, and she will talking about the NEEM project. So floor is yours. You have
Thank
20
you.
minutes.
Okay.
We will give you a buzzer at when the 5 minutes are left, and you have to wind up.
Okay.
Okay, thank you.
Perfect. Thank you. So, a very good afternoon to one and all present here. My name is Manaswini Sridhar. I am from Chennai, Tamil Nadu, and I completed my bachelor's degree at Amity University, Noida. After that, I moved on to the Ludwig Maximilian University in Munich, Germany, and there I pursued a master's degree in human biology with a specialization in brain cancer. So during my time as a student, I began working at a company called Azza Divine, and this was basically a German company that focused on NEEM. Personally, to me, this was very interesting. And what started off as a very simple student part-time job very quickly evolved into something much, much more. So today, I'm very, very honored to be standing in front of all of you as head of research of the NEEM project. So, what is the NEEM project? It's essentially a multifaceted collaboration between several of our companies, and each of these companies have different focal points, but they are all centered around NEEM. So what we're going to do today is that I'm going to take you on a little bit of a journey through all of these companies, what they do and what they plan on doing in the upcoming time. So we will begin first with NEEM Products Paraguay. It is home to one of the largest neem plantations in the world. On this, we call this our farm around the office because this is a plantation that we own, and we have around 200,000 high-quality neem trees on this farm. It is entirely solar powered, and the processing plants as well are entirely solar powered, and every step, beginning from planting of the seed all the way to the processing and production of the raw materials, takes place on this farm. We are present at every single step of the way, and this provides a higher standard of quality assurance. Now, what are these farm-grown raw materials? Well, there's different kinds. First, we have our neem leaves and our neem powder. These are highly refined and pure, and in fact, the neem powder is a very, very good candidate for nutraceutical and food supplement production. Next, we also have neem oil. This is now manufactured by our new state-of-the-art oil press and will soon be the future of our neem-based pesticides. An interesting byproduct of this process, our neem cake, is also just a cornerstone of soil enrichment and is also commercialized by us. Finally, last but not the least, we have our dried neem seeds. These are highly potent, and in fact, I'm very happy to announce that one of our recent clientele also includes a Swiss pharmaceutical company which are using these seeds. Now, you're going to come on a little bit of a trip with me from Paraguay to our headquarters in Munich. This is also where I work. And then we'll be going to our next company, which is also part of the NEEM project, Natur. Natur is a neem-derived medical skincare line. We basically make all of our products from a potent leaf extract of the high-quality leaves of the neem tree. And these products are especially catered for those with sensitive and dry skin, and also for those with dermatological conditions like psoriasis, eczema, and dermatitis. Just to show you a little bit of our own internal data, I want to show you the effect of two of our psoriasis recommended products on psoriatic skin. So this is the image of one of our customers before they used two of our products, specifically the skin balm and the cream. And this is their skin just 2 weeks after use. So this is literally a first look at how exactly our product works and how well it works. So I've been talking a lot about this potent leaf extract and how effective our products are, but I want to tell you what exactly this is, and I want to go into it with more detail. So I'd like to introduce you to NEEM, our master ingredient, active ingredient complex. It is entirely NEEM-based, and it has several active ingredients such as nimbolide, nimbin, and solanine. I again want to show some data specific to this extract, and I will be explaining it to you now. First, we wanted to show you the anti-inflammatory capability of our extract. And if you turn your attention to the graph here, you can see that, okay, my pointer doesn't work, it's fine. You can see that in a 3D skin model, when we basically induced inflammation, what we could see was that there was a very big difference between the skin model that was not treated with our extract and the skin model that was. So that is what is depicted in this graph here, and that is what interleukin-6 concentration means. It's a visual number of inflammation progression, and when the 3D skin model is treated with neem leaf extract, the progression of inflammation is much, much lower. This is an indication that our neem leaf extract is anti-inflammatory. Similarly, we performed another 3D skin model test for antioxidant capability, and we tested something called tear value. Tear value is basically a number that tells you how good is the barrier of your skin. When the barrier integrity is compromised, the tear value will fall. So that's exactly what we did. We treated this 3D skin model so that this barrier integrity would fall. And while these results are not as differentiated as the anti-inflammatory capability, one thing I do want to highlight is that the fall from before treatment to after treatment is less pronounced when the skin model is treated with neem leaf extract. This indicates that the extract not only has anti-inflammatory capability, but also antioxidant. So now I want to explain a little bit about how we get to this extract and what exactly we do. So first, of course, we have our neem leaves, which are properly processed on our farm, and then these leaves undergo a proprietary supercritical carbon dioxide extraction process. After this, we get a raw neem leaf extract, which is actually in the form of a paste. And what we do is that we mix this extract with a very commonly used solvent in cosmetic and skincare manufacture. Anyone who's in the industry would be familiar with octyl dodecanol. It's a type of oil which, when we mix with the neem leaf extract, we get NEEM. And this is our master ingredient that we then use in all of our Natur products. So it was very clear to us that we had something special on our hands, not only because the NEEM was so effective, but also because we used it in every single one of our products, whether it was for skin or hair or nails or any other part of the body. So this indicated to us that, especially with the success of Natur and with how happy it made our customers and how many patients it helped, we realized that now it was time for us and it was our responsibility to share this material with everyone else as well. So in January 2026, we created NEEM Lab. It is a company that is solely committed to commercializing this singular ingredient for other skincare and cosmetic manufacturers as well, so that they can use it and create medical skincare. Now, as I had mentioned, I am a scientist by profession, so I want to introduce you to where I work. I am very happy to announce that we at NEEM Lab and at the NEEM project have our own lab space for in-house experiments. And this, for me personally, is very, very exciting because anybody who has worked in a lab knows that they hate leaving it. So having the opportunity to do this again at my company is more than I can ever ask for. Additionally, I have a lot of freedom with experimental design, and that definitely is a really, really interesting way to learn about NEEM, because essentially, I have to study it in extreme detail. That's extremely cool for somebody like me, because I started here quite recently, and it's very, very nice to be involved in such a way and to actually be able to discover the science behind a medicinal herb that my grandmother has been telling me about since I was 5 years old. Now, I know that this is a NEEM summit, and I know we should be focusing on NEEM, but I want to talk a little bit about what makes us special slightly outside of that. So, first of all, like I said, we have a very large NEEM farm, but beyond that, we are a very, very diverse company. I mean, I'm an Indian from a German company. That doesn't happen very often. And because we are so diverse, this allows us to combine technical expertise with refined ancient knowledge. Additionally, we also take part in social initiatives. This is an example where we built a school in the Chaco region of Paraguay, which is where our farm is situated. Next, we are an entirely certified carbon credit project, so we make sure that we reduce our carbon footprint and other greenhouse gas emissions. Additionally, we follow holistic agriculture. This means that we view our entire NEEM farm as a singular ecosystem, and we treat the soil and the water and every other aspect of the farm with the same amount of care and importance as we do our NEEM trees. And finally, while we do have our own lab space for in-house experiments, we are also always pursuing research collaborations with other external companies as well. So, what is next for us and for our NEEM? I'm very happy to announce that our path ahead is extremely research-oriented, and while each company has different needs, all of them are still experimental-based, which is very, very fun for me. So, beginning first with Nimavera, while we have a very, very good formulation in our hands, we do want to develop it further and have various versions of it. The first of which might seem very interesting is a Nimavera that is not green. I know this seems quite controversial, but then the reason we would like to do this is because sometimes when it is used in products in slightly higher concentrations, it might leave some sort of a green cast. So from a consumer perspective, we are trying to see if maybe we could remove the green. However, this poses a lot of really interesting questions. What if, with the removal of color, some sort of efficacy vanishes, right? What actives are actually contributing to this color, and what would happen if we remove them? It has a lot of questions that need to be answered, and I am very, very excited to discover them. However, at the same time, if anybody has any suggestions for how to go about this or any ideas, I am very open to hearing them. Our next formulation version is that we want to make a Nimavera which is soluble or at least dispersible in water. The reason this would be a good option is because it generally makes formulation a lot easier, and also for me personally, from a research perspective, having a version of the extract that can mix in water would make lab experiments a little bit easier. Moving on to Natur, as I'm sure everybody in this room is aware, NEEM is very antibacterial and antimicrobial in general. And while this is very common knowledge, as I have shown before, it is important for us to have our own internal data. And so, the upcoming experiment, which I'm very happy to have designed, is that first, we will be trying to see the effectiveness of NEEM against Cutibacterium acnes, which is the causative organism of bacterial acne. Next, we would also eventually test it against fungus and virus, but that is, of course, once the entire procedure has been properly established by me. And finally, we come to the project I am most passionate about. A very interesting fact is that this is why I joined the company over 2 years ago as a student. My company has a patent that says that neem leaf powder is effective against a neurological disorder called restless leg syndrome. For those of you who are not aware, it's essentially a disorder where you do not have control of your limbs, and because of that, there are very sudden moments where you have an urge to move them and you cannot stop it. Imagine this in case when you're driving, right? It's extremely dangerous. And it seems to have a pathway that's quite similar to Parkinson's disease, which also doesn't have a cure. However, we found that the consumption of neem leaf powder is somehow able to soften or attenuate these symptoms. And so that is something that I was brought on to figure out why. So, for this, we have a two-pronged approach, and what I will be working on is the lab and bacterial side, and I would like to talk about it a bit further, but I don't have too much time, so if we want, we can connect on it offline. But essentially what I would be doing is that there is a bacteria which people suspect might be something that causes restless leg syndrome, and I want to see if the reason NEEM works is because it is doing something to this bacteria. So it's essentially a connection between the gut and the brain, and it's very exciting. However, on another end, because of course for something like this, just lab results, while they would be quite helpful, are not enough. We have partnered with a contract research organization in India to conduct a food supplement trial where we will essentially see if the neem leaf powder helps those who either have restless leg syndrome or even tendencies of these symptoms. We want to see if the consumption of neem leaf powder helps them in some way. With that, I come to the end of my talk. I would first of all like to thank Dr. Kothari and the entire WNO community. This is my first ever conference. It's the first time I've been on a stage like this, so it's a huge honor, first of all, to be among so many laureates, and all of your papers were so interesting, and I'm really glad that I at least got to be part of that list. And of course, also thank you to my entire team at the NEEM project. They worked very, very hard. I troubled them so much before I came here. And yeah, just thank you everyone for your attention, and thank you very much.
Thank you very much. You have been managed the presentation so well. The contents were also excellent. So I really congratulate on the work which is being done. Before I throw the your presentation for the question and answer, I have one this thing. Have you characterized as NEEM Avera chemically?
Yes, we are actually, that's actually something I wanted to speak to you about offline, but that's something we are in the process of doing, because what would be great is if we had an entire ingredient list, right? But right now, what we definitely know is in the NEEM Avera are nimbolide, nimbin, and xalanin. It's mainly these three, but it would be nicer if we had a full list, and we are trying mainly via HPLC, but I think this would be something that would be better if I outsource to a bigger lab.
If you can just get the metabolomic study done, metabolomics, yeah.
Okay,
The entire metabolome, if it can be done there.
Okay.
So that
Great,
way.
thank you.
That's good. So now the floor is open for the question and answer. Yes, please.
Yes.
Yeah, am I audible? Yeah, first of all, congratulations to you for doing excellent work. And it's heartening to see a student from India, coming from MIT, and then going up this far and heading a company's R&D. So congratulations to you and all the best wishes for your future career progression. In fact, what I just want to see, it's really nice to see the products that you are working on, and the problem of green coloration that you talked about, it basically is because of the presence of chlorophyll pigment. That is largely because of the chlorophyll pigment.
Yes.
And now chlorophyll is a very, very stable, it's very stable pigment, and it's very difficult to get rid of it. Plus, since it is a part of a biological system, there are ways of getting chlorophylls, because see, you cannot do a chemical processing of chlorophyll, because if you do some chemical removal, the chemicals are harsh and they will be in the product and they will not be required. So there are other green ways of doing removal. There are 4 or 5 ways. One is ultrafiltration. But you have to make sure that when you do ultrafiltration, you do not lose some of the good parts, the nimbin, the selenin, all those should not get rid of. So you have to see exactly how it is. Then the other one is, there is one way is through photo bleaching.
I tried that.
Okay, that is with the high intensity UV, but that may also have a detrimental effect on on the active ingredients that you are using. So that is another thing. Then there is also one way of activated charcoal based
tried
removal.
That as well.
You have tried.
Yes.
So because activated charcoal can also take away some of the good things.
Yes, and that's exactly what happened. And the worst part is it took away some of the good things and left the green.
No. So I can add on the activated charcoal. Activated charcoal absorbs everything. Okay. It's absorbed. But you can do the desorption by doing the selective solvent. The same compound which is absorbed by the charcoal can be dissolved from the charcoal by using the selective solvents. I have done this.
I think ma'am is the right person to answer. But winterization is another thing.
So solvent selection is very important for doing the charcoal absorption.
Okay.
If you do the right solvent selection, where your compound is retained in the solvent, whereas the undesirable components are absorbed on the charcoal is an art.
It's an art, and I think
It's an art, and you can do this.
and it's a very delicate chemistry behind it. So I think, but for that, the GCMS profiling of or metabolomics maybe needs first to be done.
Yeah.
But then there is another process you may try that is called winterization, which is like extreme low temperature precipitation of pigments. Sometimes it takes place. You have to. I also don't know, but
Okay.
this is a winterization is a process where you can actually be able to precipitate the pigment.
Okay,
You
I'll
may,
try
you
that.
may explore and do research on that.
Great,
Thank you.
thank you so much.
But I would suggest there's very simple method by which you can remove the chlorophyll. We can discuss this offline.
Okay, thank you, thank you.
Thank you, Manaswani, for developing very science-based products.
Thank you.
Whether you have worked on neem oil for developing any fungal disease control?
Not yet, sir. Actually, right now, we're almost like redeveloping new neem oil because we have a new press. So that, I think, we would be using for neem-based pesticides mainly. But then, do you mean like fungal skincare?
Skincare, yes.
No, sir. We haven't done that yet because also we are a little bit worried about the azadirachtin content. Of course, with the new neem oil, we don't know how much will be there. But I think because of that, we want to maybe stick to the extract. But yeah.
So one more, I have a question. Why did you choose supercritical extraction? Why not the other extraction?
So
because that's very expensive, supercritical extraction.
yeah. The thing is that this is, it's a proprietary method. We're waiting for the patent.
I know.
And
I know.
Supercritical extraction may be expensive for us. For in certain areas, it's very economical.
No,
Plus-
but the same
plus-
extraction can be done
No,
by
no.
solvent mixtures.
No,
Same kind of efficiency.
No, plus there is no solvent in that. In supercritical extraction, there is zero solvent. For human application, for cosmeceutical application, and for certain nutraceutical application, supercritical CO2 is preferred over solvent extraction. And if you go for solvent extraction, there is a possibility that oil may also come in.
Yes, it will. It contains all
So
polar
thank
and
you very
non-polar.
much. Thank you. It was a wonderful presentation.
But
Wonderful presentation. And as suggested by our chair, she ensured that none of us fall asleep. It was a very interesting topic which made everybody sit back and watch it. We are very thankful to you, and this gives an idea like what we are discussing yesterday and today, that we have to broad base our NEEM based applications. This is one area where we have to concentrate on in the human health, and maybe they are thinking of cosmeceuticals. It looks like that. We have to concentrate on it. Thank you very much, Ms. Mansvi. Now I request you to come to the center of the stage to receive the
Now, I would like to invite Mr. K. Swami for his presentation.
नमस्कारम मेरे सारे प्रिय दोस्तों एडवाइस लेने वाले और देने वाले सबको नमस्कार वो डाइस पे बैठे हमारे जज को विनंती कि ज़्यादा से ज़्यादा मार्क हमको देवे। मेरा नाम के स्वामी है। मैं इंजीनियर भी हूँ, साइंटिस्ट भी हूँ, और क्या क्या नहीं हूँ वो बताने की जरूरत नहीं है, क्योंकि टाइम यहाँ कड़ी घूम रही है और मुझे बोलना जरूरी है, आपने समझना जरूरी है। सबसे पहले मैं WNO को थैंक यू करूँगा, उनकी सारी टीम को भी थैंक यू करूँगा जो मुझे बोलने का स्टेज पे छोटा सा मौका दिया, लेकिन छोटा डायमंड के माफिक है। थैंक यू। First of all, I would like to ask you, anybody know what is grinding? Well, now, I go ahead. Grinding means size reduction industries. The grinding is a different kind of principle, and even this principle, I would like to give you some information. And this is the information that in the world, grinding and a size reduction take place all four type of mechanism. First is a compression technology which roller to roller grind together. Second is sharing, like every day in the kitchen, people cut with a knife, that called sharing. Third, impact, anything you use hammer to grind, size reduction. Third, attrition, every children knows they played concha, particle to particle collide. So there are some machinery is principle working, and the micronizer, which I already shown you, is working with the three principles: sharing, impact, and attrition. So 1 power, 3 attrition. Now, when you are making size reduction, no size reduction take place without losing properties and increase the temperature. This machine, micronizer, is made for avoid this property loss, nutrition loss, medical property loss, moisture problem, powder liquid mixing problem, powder or oil coating problem, problem of powder classification, problem of particle size distribution, powder mixing problem. This is all problem. If you like to have something example of this, I have an email and stall is outside. You can take the card and write me on a mail. Otherwise, I cannot complain in 20 minutes this 2 hours job. So now, the grinding with high speeding but not increasing temperature. You can grind any product. Increasing the temperature, no. And size reduction, yes. In this space, you can grind and dry. In fact, dry and grind, which means you have a live product from the tree, you put in the machine, and within a 6 seconds, it will be converted into the powder dry. Whatever you would like to put drying method is called attrition mill. Now, we can give also a cryogenic grinding machinery, which you can grind any product under the -5 degree temperature. So, in this case, our objective is how to maintain hygienic, no loss nutrition and medical property, higher production efficiency, improve the environment, reduce the product contamination, quality and finished product quality awareness, increase the shelf life of the product. This is a very interesting subject. If any product of yours have a no shelf life, please contact me, advice is free by the way. And constituency and informality, yeah, even particle size, and production loss recovery. So in this case, the particle, when you hammer, there is a different kind of particle. When you make a knife, there are different kind of particle. But in microanalyzer, septomicroanalyzer, is a production is a cut, after cutting, if you see from microscope, it is a round product. So effect will be very good for the all further recovery. So this we research for Ayurveda market, NEEM market, and other industries, food industries. And by the way, whatever flying while you are grinding, that is not a loss. This is your product. Money is flying. If I put plant here, and I guarantee atmosphere will be same, even though this machine is ready. Now I'm talking about the instant drying grinding. I will show you the video also. First, the product, neem leaf will be washed. Second is blanching. Third is to remove the peripheral moisture. Then conditioning, pre-crushing, and then we put hot air, and in 6 seconds, drying and grinding, 65% moisture will go away. And if you want to increase or decrease moisture in the product, is automatic. You have nothing doing, just in 2 seconds you can adjust this. Now I show you the video. Please see carefully. And this
Welcome
is a
to KK
practical.
Consultant and Engineers India. Our headquarters is in Gurgaon, Haryana, and our cutting-edge machinery serves various industries including Ayurveda, pharmaceuticals, chemicals, minerals, and more. Our production facility manufactures high-quality machinery built to global standards, ensuring performance and reliability. After 15 years of dedicated research and development, we have created a cost-effective solution for fine grinding and instant drying. Introducing the Septu Instant Drying and Grinding Plant, a revolutionary system designed to handle up to 60% moisture. The processing time from raw material to powder will be 6 seconds, ensuring that all medical properties and nutritional values remain intact. Here's how it works. Freshly plucked and washed neem leaves are fed directly into the Septu micromeasure. A hot air generator powered by an automatic gas burner supplies the heat. Hot air and leaves enter the micromeasure. As the leaves rotate at high speed, moisture is separated, generating humid air. Inside the cyclone separator, the powder and moisture are efficiently separated. The dry powder collects below, while moisture exits through the pulse jet filter or exhaust fan, ensuring a dust-free, eco-friendly process.
Now, I didn't hear any clapping anyhow. Because we take lot of time to make this one only for this function. Now, you see the drying capacity, then you have to put some energy. And grinding, size reduction, you have to put some energy. But in this case, the grinding energy is fully recovered by drying capacity. So you are paying one cost for drying or grinding, second is free. Buy one, get one free. Suitable, sensitive biotechnicals and prevent of other physiomechanical degradation is not placed anywhere because we don't give heat directly to the product. We give heat to the air, and air carrying the high speed velocity and take the moisture away from the product. Then eliminating all separate drying and grinding. You don't require two plants. One plant everything will work together. Uh, there is no post uh, processing like a preheating or nothing. Maintenance is, you can say, bacteriology, color, name, leaf, remain, everything, including safe life of the production, bacteriology, level, precise the outlet of moisture, which I talked to you, 10 seconds you can adjust the moisture at outlet, precise outlet moisture, can function independently as a dryer and grinder. Hygienic, easy to clean, and assure you GMP model. Drying time is 6 seconds only, drying and grinding both. This is also another which coating and drying plant, but to explain it will be too lengthy. Calculation, you have everyone, okay, consistency of particle size. Very good. Particle size, I told you before also, the uneven particle don't give you further process a good result. So in this plant, you have a round particle only, and it gives you a good result while mixing. Grinding, coating, yeah. You see, I was talking about the fertilizer. What is the fertilizer you have plant? Urea. Urea coating with the neem powder. You see, in some other product, if you want to coat the neem powder, first machinery, IDG plant, you can inject any chemical, any product, it will be coated, all particle will be coated with that product. So coating is not required separately. Grinding, mixing, coating, drying in one machine. Increasing production efficiency, reduce the labor, time and requirement of regrinding. Regrinding is not there, it's automatic inside, inbuilt. So once a product will come, is directly, you have in a final mesh size or micron size. One thing I would like to talk to here, 15,000, 15,000, 15,000, 15,000 divided by mesh is equal to micron, and 15,000 divided by mesh is equal to micron, and micron divided by is equal to mesh. This is the confusion everywhere. Okay, what is the mesh size and what is the micron size? Figure it 1. Take the 15,000, divide it, second result will be there. No calculator, no mathematics, right? Then Ayurvedic product we can grind here. Also, yeah, another one. I see so many plant or so many places, they make a tablet. And they come to me, KK, you call me KK or Swami, it doesn't matter. KK, our tablet, out of 100, 10%, 15% is broken. So they have some shifter, they clean it and recycle the powder. So you are losing medical property. In here, you have to decide what particle curve you require. So nobody knows curve. This is the problem. Maybe somebody knows very well, but the curve is something else shape. One side is fine, one side is percentage. And once you put the curve, where to cut? This particle is good for the tablet and this is no good for tablet. And once you know the particle size, you adjust the machine. You will produce the same particle. So I say 99% you get the result successfully to make a tablet. Then whatever quality standard you require, same size production. And important future enhanced, hygienic. There is no pollution. One factory, they asked me to please visit, we have a very good plant. I went there, And then first of all, everything okay, helmet, coat, everything. They give me 2 masks. I said, why? Why I have to put 2 masks? A little pollution is there. And inside, when I went inside, it was a machine was not coming from the power bag. It was coming from the machine, and it was all powdering. And my coat was, I went with the black coat, come with the white coat. So this type of thing is I seen in the plant. So there is no pollution. And once you do anything you grind or I guarantee 100% property of raw material will you find same property in the finished powder. And this is the thing, if you like to see practical or you want to do the practical, factories in Gurgaon, 30 kilometers from Delhi, you come with your 10 kg of product and we give you live demonstration of your product and you check, make a result yourself. But only thing, before coming, please inform me in advance, so we have to prepare machinery. We have a coffee different type of R&D plant which is running at site. And if you want to make a test of our machinery, we have a pilot plant also, which we can send you at your site with a little cost. So I am in a time because I want more marks from my lady. So anyhow, so I can say thank you very much to hear me, all of you. And if you don't hear me, I am here.
Thank you, Mr. Swami. Very interesting machine you have developed. What is the lowest particle size you achieve in this machine?
Pardon?
What is the lowest particle size you achieve in this machine?
Lowest particle size?
Yeah.
Oh, very good question. 5 micron.
Okay, good.
5 micron.
Yeah. 3,000 mesh. Just convert with the 15,000.
So, any material can be grinded in this one, or only this is for the neem leaves?
Any material you can
Biological,
grind.
biological.
Any material you can grind inside the
Any-
product should,
any fresh
product
material.
should be grindable. If you put the diamond, cannot grind.
I want to grind the diamond.
I give you diamond, I cannot grind.
I will take the diamond from you.
Any questions now from audience?
Welcome, sir.
Thank you so much.
Thank you, Doctor. Very interesting, and I will say it's a different thing which we have learned today from Mr. Swami. He has been in the industry for so many years. We know that we can use his services for making our neem leaf powder or anything. Thank you, Mr. Swami. Please come to the dais to receive the... I request Mr. Milan Mehta to come to the dais to honor the speaker.
एक ही कप